40 millivolts. You see it here bouncing a little bit back and forth. So let's assume it is 40 millivolts. Okay. Now the 7 dBm, because that is the level what our specs are telling is or should push for 10 dB signal to noise. So let me switch it in. Here our minus 107 dBm, and I have to go to the 300 millivolt scale, which is now this here, and yeah, it is again, you may hear it, it is still in the noise. Okay, so that is the meter, which is freaking out here a little bit, but yeah, so it is, let me say it is 200 and let me switch it off. Let me say it is 280 millivolt. Okay, so now we have both. We have the, let me switch out here the speaker. So now we have both. We have our noise level with 40 millivolt, okay, and we have our signal level, which is 280 millivolt. And as you have seen it in the specs, the ratio is always given in dB. So that means we have to work out what the dB is now on this both noise and signal level. So that is what we want to know. Yeah, again, let's have a look here back on our specs, and once again, so we are in AM mode, and greater than 1.5 megahertz, so we are here on 14.1 megahertz. We should see with 1 microvolt, or with which is similar, minus 107 dBm, we should see minimum 10 dB, right? And yeah, now we need really to convert our both figures. We have our 280 millivolt for signal and our 40 millivolts for noise. We need to convert it into dB, okay? And therefore we have here the formula. Let me go here that you can see it. So the formula is 20 times logarithm voltage signal to voltage noise. Okay, so that means as we know, we have 280 millivolt by 40 millivolt, right? And with this both figures, we should be able to figure out here our dB value, which is what we have once again mentioned here in the specs, 10 dB. So minimum we should see with these both voltages, we should see minimum 10 dB. If it is better, so if we have a higher dB, so the distance between noise level and signal peak is higher, so that is what we have here, right? If this here is greater than 10 dB, then it is good. If it is lower, then you know, our radio is not fulfilling its specs, and therefore it was interesting to set the generator exactly to minus 107 dBm to see if the radio is able to get out of it our minimum 10 dB, okay? Right, now we only need to put it here into our calculator. So I try to do it here around the camera. So 20, okay. Then we need to use our logarithm button, and of course I set it here this way because here our signal was 280 millivolt, so that means minus 3, okay. 10 exponent minus 3 is millivolt, okay, and we have 40 millivolt for the noise level. So I put in 40 millivolt, which is again minus 3, okay, and then of course I want to see here the result. Oh, I don't know if you can really see it very well. Okay, once again, so that is the formula I have now here typed into my calculator, and now I'm pressing the equal button, and let's see what we get. Yeah, you see once again here our formula, and you see the result. So the result is 16.9 dB. So that means our signal is 16.9 dB over our noise level, and that means with minus 107 dBm, right, our radio is performing better than the specs are asking, and that is great, right? That is really great. And yeah, now you know everything is fine with your AM receiver path, and you can definitely tell everything is good. And once again, you only need two testers or two meter and signal generator, so let me say it that way, to be able to do this testing, okay? Okay, and let's see what the tester is telling us. Once again, we have here on our calculator 16.9, so let me say roughly 70 dB, and have a look. Here it is very close to what our tester is telling, and I'm testing here for SINET, so that means that we do not have an additional distortion on the signal, so the harmonic distortion, which is within our SINET signal, seems to be fine, okay. Once again, here our signal, the tone, so you hear, of course, there is noise in the background, but you see we do not have a problem, obviously, with one stage, so maybe especially with our audio stage, because you know, when I test for SINET, I am getting very, very close to the signal plus noise to noise value, and therefore if you do not hear a distorted signal, audio signal with an S9 level, so if the voice or the tone is really clear, so that you more or less have a good and pure sign, then you can assume that the signal plus noise to noise measurement is very close to the SINET testing, and that is what we definitely see here. 16.9 we have on our calculator tested with our audio voltmeter is very, very close to what here our modern radio communication tester is telling us, and therefore that is the proof that what we have done with our simple voltmeter and with our little formula is very, very much comparable, right? Well, okay, what does it mean? So if you do not have a SINET meter, and if you have real AC voltmeter, and once again, AC voltmeter means you need to have a true RMS meter, right? So that is very, very much important. You cannot use your cheap multimeter, even it has an AC setting, but the cheap multimeters do not have a true RMS mode. So let me show what I mean. So modern multimeters do have true RMS capability, and that means even if a signal is not a pure and crisp and clean sine, the multimeter is able to really display the right RMS value, because the cheap meters, which are not able to use or to have the capability of a true RMS display mode, you have to, or you need to know that you cannot test audio. This meters are normally made for main, so for, I don't know, these meters are working from maybe 40 hertz up to maybe 100 hertz. There you see that these meters are made for main power, which is normally within 50 or 60 hertz wherever you are here on our world live. And these simple multimeters can't be used for this testing. So you need an AC true RMS meter to be able to do this testings, because it is not a clean sine what you're testing for. If you have a very weak signal, it is definitely no sine, and therefore this is here very crucial to have to be able to do these testings. Okay, so that's it for today. I hope this all brought a little bit light into the dark. And if you understand the theory, then it is really easy, because you can do it with a meter and a signal generator, which you have the capability to set the dBm or microvolt level. So that's it for today. I hope it was a little bit helpful to you, and you can use all this information to be able to do your own testings. Okay, thanks for watching, and catch you next time. Bye. Hi and welcome to TRX Bench. Here today on the bench we have a Alinco DR570, and this radio is not receiving on 2 meter, so 70 centimeter seems to be okay, but let's really double check what's going on here. So I've already connected it to the tester, and the generator is sending into the radio already, and we really should see here a full S meter, but there is really nothing. So let's really check what we have here. Okay, and we see that we are here testing already, as I told you, on 2 meter, And yeah, we are here at our 12 dB point. So our synod here is bouncing back and forth a little bit. That's because we are in the noise. But you hear in the background the signal, and maybe I can increase it here just a little bit. But you see, we are peaking here the 12 dB point. So that means definitely what we are testing for, and you see we are really putting in a lot. So minus 53 dBm, and you might know on ultra shortwave radios we should see S9 at minus 93, right? And we are as high as minus 53, which is much higher, and we are still in the noise, and yeah, just peaking our 12 dB point synod, as you can see it down here. So that really means our radio is completely deaf. Looking here onto our receiver specs, we see that our 12 dB point synod should be at minus 16 dB microvolt. So Linko is giving these figures in dB microvolt, so we need to convert it to dBm, or maybe whatever you are more familiar to microvolt. Alright, so let's see what really minus 16 dB microvolt means. Yeah, and looking here onto this table, we see that minus 16 dB microvolt means minus 123 dBm, and that is much more familiar for the most of us, I believe, and that again is equal to 0.16 microvolt. And we have seen that we are peaking the 12 dB point with minus 53 dBm. Yeah, and that simply means that we are really missing 70 dB. So yeah, the radio is totally deaf and is definitely not able to receive nearly nothing, right? So let's check our 70 centimeter band to see if that band is working as it should, alright? Alright, but before I dial in the new frequency, let me drop here my level, the generator level, to minus 93 dBm, because with minus 53 dBm I'm really blowing out the hell out the radio. So alright, minus 93, which is an S9 level, and let me go over to our frequency dial, and radio is set to 430, what is it, 100 megahertz. And let's see what we have here. I do not see nothing so far, but now. Alright, so here we are. Here is our tone. I switch it off, and you see here we peaking 40 dB synod with minus 93, which is really nice. So let's have a look here on our S meter on the radio. And yeah, you can see it here. So it is S9 and peaking S9 plus, as you can see. So that means our S meter is obviously good and precise aligned, so no problem. And I can bring it over to the main receiver, and yeah, here it is, and it is still exactly the same. So you hear on 70 centimeter it is working just fine. So we definitely have a problem on 2 meter where we really have no receive. Additional to that is we see here, so there seems to be a light bulb defective as well, but that is not our main issue so far. Okay, so before we go ahead, let's test our transmitter. So first on for 3100, so on 70 centimeter. So let's see, so that is low, and yeah, so it is working 3.4 watt, and I also see that the radio has deviation, so that means audio seems to work as well. Okay, let me use the high position. So this radio only have high and low, so let's see what we get out of high. 23 watt. So okay, so that is fine. Now let me switch the radio to 2 meter, right, and let's test the transmitter over there. And alright, so we have 4.8 watt, which is fine on low, no problem. Yeah, deviation is given as well, but it would make me wonder if not, but anyways. So let's go to high, and let's see what we have. And we have, ooh, what is that? On high. Alright, so we do not get output power on high. That is interesting. But again, we get output power on low, but for any reason, once again, no, that is funny. So on high, we do not get any output power. So that is interesting. Again, let me check here on, yeah, no problem, on low, 5 watts, very nice, no problem. High, nothing. That's interesting. Okay, anyways, let's start with our receiver, and then let's check what's going on. So therefore, let's crack open the radio, and let's check for anything obvious, and then we will see how we can go ahead. Okay, and here we have our radio open, and this side here with mainboard and power board is VHF, and when we flip it over, so we have here main and power board for 70 centimeter. And yeah, when we look around here on our VHF power board, so we directly see here a burned out resistor. So that might be the reason for not having high power on VHF. So we have to check that. But yeah, additional to that, of course, we want to see if our signal is going through our duplexer and finally here through our power or amplifier board, as this is here our output out of our duplexer, which is this thing here. And so we should of course see here at this coax cable, we should of course see our incoming signal, and then it goes through our power board and will enter the main board, I believe through this cable here. So we have here a little coax cable, and we will enter in here. So what we can check is if our signal is entirely coming through and will be available here at our input to the main board, and of course we have to follow, if necessary, through the main board as well. But additional to that, we have to investigate what's going on here with our resistor. Okay, so the situation here is a little bit weird, as we have here, well, a well-known module, power module in, so the M57726. So that is a normal VHF power module. So, you know, I have a different drawing here on our schematic, and I doubt that the schematic I have is completely valid here for this version. Okay, so you see here our VHF power module or amplifier schematic, and what we see is that we have here our IC, so our power module, and you see that we have 5 pins connected, and what you see is that we have here an FB, so-called FB wire, which is supplying here our module with voltage, and when we go here through our unit, I can enlarge it, and you see we have here a little power source unit, and we see here our FB, which is directly connected to our amplifier board. And finally, when we go over here once again, here is, no, you can't see it, let's see, so we have here our FB input, and you see it is straight going on to 0.4, which means we should see all the time our 13.8 volt, because that is simply our input voltage, at our module. But when we go down here to the board, you may see, let me see if I can do it a little bit better, maybe that way. So you easily can see that here our power module only has 4 pins, so here our middle pin is not connected. So I wonder if this is here the original one, or is it simply a different version. But additional to that, I have here, of course, our data sheet of the M57726. And what we can see is, I hope you can see it, that pin 2 is our first DC power supply, and point 3 or pin 3 is our second DC power supply, right? And when we go down to the board, if I go down here to pin 2, let me do so, we see that I have no voltage. I mean, that is not so critical, because as far I press here PTT, you see nothing. That is nice. Yeah, I should put ground here to the chassis to be able to read here any voltage. Again, without doing anything, we do not see a voltage, but then when I press here PTT, you see I see 9 volt, which is funny enough. And when I go and switch here to what is it, low, I believe, yeah, it must be low, and I test then again here this point, we see 5 point whatever 8 volt power supply here at our power module, which is funny enough, because normally I should see according our schematic, we should really see our 13.8 volt, what we don't. So, you know, I am really already wondering if this is, a more critical and serious fault. I mean, of course, we can repair it, so that is not the question, but I mean, it is always a question what should be invested in a radio of this age. So therefore, I mean, it looks like that we do not have the right schematic, I mean, at least for our power module. What we know is that we have here our burned resistor, so that is the second power line which goes over this resistor to our module as well. So question here is, why is this resistor burned out? So is there a short in our module? If there is a short, then that would mean this module needs to get replaced. I mean, okay, all is handleable, so that is not the problem, so we can manage it for sure, but it is always a question of money, what the owner wants to put into it. And additional to that, we still have our receive issue, that this radio is completely deaf. So next step, I want to make sure that our incoming generator signal is finally getting here to our main board, that the signal is passing through here our power amplifier board to our main board, to be able to see where we are losing our signal. And if it is going through, then additional to this power issue,